Hello everyone, I welcome you to the ninth lecture of Applied Thermodynamics subject. Today's topic is psychrometric process. So here you can see there are so many psychrometric processes which are shown. The first one is the sensible heating, and next one is the sensible cooling. Then the third one is the humidification, or you can say the humidifying process. Fourth one is the dehumidification, or you can say the dehumidifying process. Then the fifth one is the heating and humidification process, or you can say the heating and humidifying process. The sixth one is the cooling and dehumidification process, or you can say the cooling and dehumidifying process. And here is the seventh process, which is the evaporative cooling, or you can say it is the cooling and humidification process. And here is the heating and dehumidification process, or you can say it is also shown as the chemical dehumidification process. So here all are the various types of psychrometric processes. So first of all, let's understand what is the sensible heating. So here in this term sensible heating, what happens that say here is the first point number 1, and here is the point number 2. So if you join this line 1 to 2, if you join this line 1 to 2, then this 1 to 2, which is the known as the sensible heating process. 1 to 2 is in this chart is known as the sensible heating process. So in the case of sensible heating, you can see the value of dry bulb temperature which gets increased. The value of dry bulb temperature which gets increased from 25 to 40 degree, for an example. So here in this case you can see the value of a dry bulb temperature in the case of a sensible heating which gets increased, and the value of the humidity ratio, or you can say the value of specific humidity in the case of a sensible heating which remains same or which remains constant. So here you can see there will be no change in the value of specific humidity. So for any types of sensible heating or cooling process, we can say that the value of humidity ratio or the value of specific humidity which remains same. And here you can see there is a change of wet bulb temperature during this sensible heating process. So here first of all, the value of wet bulb temperature at point 1 and at point 2. So here you can see there must be increased in the wet bulb temperature during the sensible heating process. It means that the value of wet bulb temperature which gets increased during the sensible heating process, and also the value of enthalpy which also gets increased from H1 to H2, and also the value of a specific enthalpy from point 1 to 2 for any sensible heating process which also gets increased. And here you can see the value of phi, or you can say the value of relative humidity which gets a decrease during the sensible heating process. Here you can see the value of phi is 50%, but here at point 2 it becomes near about the 20%. It means that the value of phi, or a value of you can see also this is known as the symbol mu, which is the value of relative humidity which gets decreased during any type of a sensible heating process. So here you can also draw the separated of this sensible heating chart. So from here you can also see this all the effect that we have discussed that the first of all the value of dryable uh, temperature which gets increased, and here you can see the value of water vapor in the case of kg per kg of dry air, or here you can see the value of W specific humidity or humidity ratio which remains same, the value of enthalpy which gets increased, and also the value of wet bulb temperature gets also increased, and here the value of dew point temperature during the sensible heating process which gets the same or which gets equal. So here there will be no change in the value of dew point temperature. So value of dew point temperature at point 1 and at point 2 which remains same during the sensible heating process. Similarly, the next one which is the sensible cooling process. So what happens in the case of a sensible cooling process? Let's understand. So here is now say point number 1, and here is the point number 2. Here you can see the cooling is done. It means that the value of a dryable temperature must be decreased. So here you can see at point 1 the value of a dryable temperature is 40 degree, but at point 2 it is equal to 25 degrees. So here you can see the value of a dryable temperature during the sensible cooling process which gets decreased, and here also the value of a specific humidity which remains same, and also similarly the value of a dew point temperature at point 1 and 2 which also remains same. So now what's about the wet bulb temperature? So let's find out what's happening in the wet bulb temperature. So here is the point number 1 and here is the point number 2. So here also the value of a wet bulb temperature which gets decreased in the case of sensible cooling process. And here at point 1 you can see the value of phi is near about 20%, and at point 2 it becomes 50%. So it means that the value of relative humidity which gets increased in the case of sensible cooling process. And here from 1 to 2 the value of specific enthalpy which gets a decrease in the case of a sensible cooling process. So that's all things happen in the case of sensible cooling process. So if you want to draw the sensible cooling separate on this chart, then you can also shown by this point number 1 to 2, and here you can see the whole process from this 1 to 2 is known as the sensible cooling process. And as we already know now that the value of a dryable temperature during the sensible cooling which gets decreased. So here you can see the value of dry bulb temperature which gets decreased between point 1 to 2, and here also the value of enthalpy which also gets decreased. So here you can see the value of enthalpy from H1 to H2 which also gets decreased, and also you can see the value of a wet bulb temperature which also gets decreased from point 1 to 2, and here the value of a dew point temperature as well as the value of specific humidity or humidity ratio which remains same, and also the value of phi, value of relative humidity phi, the value of relative humidity which gets increased from point 1 to 2. So this all happens in the case of a sensible cooling. Now the next one is the humidification process, or you can say the humidifying process. So what's happened in the case of humidification process? So let's understand. So first of all, here is a point number 1, and if we are doing the humidification process, then we must go the straight vertical upward. So here is the point number 1 and here is the point number 2. So first of all, during the humidification, or you can say that during the humidifying, the value of a dry bulb temperature which remains same or which remains constant. So during the humidification process, the value of a dry bulb temperature which remains same or which remains constant. And here you can see the value of specific humidity, or you can say the humidity ratio which gets increased. It means that now the moisture content which gets increased inside the air. So here you can see the value of specific humidity, and here is the value of specific humidity at point 2. So here you can see the value which gets increased. It means that there must be added some amount of moisture into the air or into the dry air. So here you can see in the case of humidification, the value of humidity which gets increased, or you can say the value of water vapor which gets increased during point 1 to 2. And now the value of a dry bulb temperature which remains same or which remains constant. So now what happens in the case of wet bulb temperatures? So here is the point number 1, here is the point number 2. So in the case of wet bulb temperature during the humidification process, it gets increased, and also the value of enthalpy or specific enthalpy which also gets increased during the point 1 to 2. And here also the value of phi, or the value of the relative humidity which also gets increased from point 1 to 2. Here is say point at point 1, say the value of RH is near about 30%, but here you can see at point 2 it becomes 55%. So here you can see the value of RH which gets increased during the 1 to 2. So here you can say the value of relative humidity, or you can say value of phi which gets increased during the process 1 to 2. And here also the value of a dew point temperature from point 1 to 2 which also gets increased. So the value of a dew point temperature which also gets increased from point 1 to 2. So these all things are happen in the case of humidification process. So now similarly in the case of dehumidification process, or in the case of only dehumidification or only the dehumidifying process, what happens, let's see. So in the case of a dehumidification process, so identify the point number 1. So we now must go to the vertical straight line and towards the downward direction, which indicate the which indicate the dehumidification process, or you can say only the dehumidification process or dehumidifying process. So in that case also the value of a dry bulb temperature which remains same or which remains constant. And here you can see the value of specific humidity from point 1 to point 2 which gets decreased. It means that there must be a value of moisture content which gets decreased from the air. So here you can see the humidity, or you can say the humidity ratio, or the value of specific humidity from point 1 to 2 during the dehumidification process which gets decreased. And here also the value of wet bulb temperature WBT. So here the value of WBT or wet bulb temperature which also gets decreased from point 1 to 2. And similarly the value of specific enthalpy which also gets decreased from point 1 to 2. And also the value of dew point temperature which also gets decreased from point 1 to 2. So the value of dew point temperature which also decrease during this process 1 to 2. And here you can see the value of RH, or the value of relative humidity which gets also a decrease from point 1 to 2. So here you can see all the values which are decreasing in the case of dehumidification process. Now the fifth one is the heating and humidification process. So here you can see heating and the humidification process. It means that heating means that the value of a dry bulb temperature that must be increased. And here is the humidification process. It means that the value of specific humidity that must be increased. So it is the combination of our heating and the humidification process, or you can say it is the combination of sensible heating and the humidifying process, which is known as the heating and humidifying together. So in this case, what's happened, let's understand. So here is point number 1, and say here is the point number 2. If we join these 2 points, then this process which becomes a heating and humidification process, because at point 1 you can see the value of a dry bulb temperature is 35, but at point 2 you can see the value of a dry bulb temperature which gets 45. It means that the value of dry bulb temperature which gets increased. And here also you can see here is the point number 1 and here is the point number 2. So from point number 1 to 2, the value of humidity ratio, or you can say the value of specific humidity, which also gets increased. So here you can see the value of dry bulb and a value of humidity ratio both increasing together. So it is the case of heating and humidification process. So here also the value of wet bulb temperature which also gets increased, and also the value of specific enthalpy which also gets increased. And here you can see the value of specific humidity, the value of, or you can see the value of relative humidity which gets slightly decreased. So here you can see the value of humidity, and here is the value of humidity. So at point 2 its value is near about 40%, but in the case of first one it becomes more than 40%. So you can see the value of relative humidity which gets decreased. So here all about the heating and humidification process. So it is the in this process the heating and humidification both things are going together. In a short, it means that humidification, it means that you are increasing the moisture content in the case of dry air, and in the case of dehumidification it means that you are now removing the moisture from the dry air. And in the case of heating, it means that you are increasing the value of a dry bulb, and in the case of cooling it means that you are decreasing the value of a dry bulb temperature. So here is the heating and humidification process. So first of all, here is the point number 1, point number 2. So here you can see the value of a dry bulb temperature which gets increased, and also here you can see the value of water vapor or the value of specific humidity which also gets increased, or the moisture content which also gets increased, and also increase in specific enthalpy, and also the increase in wet bulb temperatures, and also increasing dew point temperature. So here you can see all the things are increasing, except and in this case the value of relative humidity which also gets increased. Here is a value is less, but here is the value of more. So in the case of also the value of RH which also increasing in our case. So here you can see all the values or all the parameters which are increasing in the case of heating and humidification. So here you can also draw the separate figures of all these cooling, or you can say all these various different psychrometric processes. Here you can see, you can also draw the diagram for this cooling and dehumidification, and also for the evaporative cooling, and also for the chemical dehumidifying, and you can also understand what about the psychrometric charts having the so much values which gets increased or which gets decreased during this particular process. So here is the various psychrometric process which is indicated on this psychrometric chart. So you can also draw this spatial diagram, or you can say the single diagram for each and every process of psychrometric chart. Like this is the chemical dehumidifying, so you can also show in this manner from point 1 to 2 and say what happening to the all the rest various properties. Similarly, in the case of evaporative cooling, you can also draw the psychrometric chart, and you can also mention the separate process 1 to 2 and then you can tell what happens in the all the various parameters of the psychrometric properties. And in the case of cooling and dehumidification, you can also draw the separate chart. In the case of cooling and dehumidification, you can also draw the separate chart. So from point 1 to 2, and now you have to draw this chart and also explain all the changes which are happening in the psychrometric terms. So here is a question for you. Enlist all the psychrometric processes and show it on a psychrometric chart individually. It means that here you can see there are total 8 number of psychrometric process. So you have to draw the 8 separate psychrometric chart diagrams to indicate all the various psychrometric process. So you have to solve this question and send it to Google Classroom.